This is the first video of our next unit, which has to do with attractions between molecules. You can see that I have a penny sitting on a lid. It's a dish lid. And what I'm going to do just to start this unit is to put drops of two different liquids on to the penny. So here we go with the first one. This is rubbing alcohol. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. At that point, I've got to refill my container or my dropper, so hang on. That was 14. 15. Oops. So at the 15th drop, it overflowed. Now we're going to try it again with water, but we're going to write that down. Oops, I spilled a little bit over here, but here's my data table. I've done it a couple of times, and again, last time I was able to get 14 in, this time 14 again, so it's pretty consistent. Now we're going to try it with water. And I'm going to try and dry this fairly well, so I'm just going to lay my camera down, so things are going to be blue for a few minutes for you. Okay, now I've cleaned my penny, I got it dry. My paper towel was getting wet. And I'm out of Kleenex. Some of you might be in the same situation. So there we have a penny back again, a dry penny, sitting on the dish lid. Get some water out of my cup over here. I should say thank you to the Schnucks pharmacist who gave me the dropper yesterday when I said I needed to borrow one needed one to do a chemistry demonstration. He just gave it to me. All right, so here we go. Now we've got the penny again. I think you can see pretty well from the cross section, so I'm going to try and be careful. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So we are able to get 20 drops in before it overflowed. So you can see in my previous trials, I was able to get 22 and 24. So we can tell that it is possible to get more drops of water on the penny than it is rubbing alcohol. Now the reason for that has to do with the way the molecules are made and also something called electronegativity. You may remember that electronegativity means attraction for electrons. So an atom's electronegativity is a measure of the atom's attraction for electrons. Technically, it's attraction for electrons that are in a chemical bond. So we're going to learn how the shape of the molecules and the atom's individual electronegativities or attraction for electrons influences how molecules act in regard to each other. So things that you normally may not think about every day, but things like boiling point, melting point. Why are some molecules really, really easy to boil or really evaporate fast and others don't? For example, we know that gasoline evaporates real fast. Water doesn't evaporate so fast, and honey is even slower. So what is it about molecules that makes them separate at different rates? depending upon, at the same temperature, some of them may evaporate real fast and some of them may evaporate real slow. So what is it that causes that to happen? And that is what this unit is about.